For more than a year and a half, I have observed the object we now call 3I Atlas, long enough that its distant glimmer has become something like a companion, steady, rhythmic, familiar in a way that almost unsettles me. Night after night, through cold observatory domes and the mechanical heartbeats of tracking instruments, I've learned its small hesitations, its faint pulses, the gentle irregularities in its brightness that speak to me more clearly than the passing conversations of my own life. It is strange, perhaps, how an interstellar visitor can begin to feel like a presence rather than just a point of data. But that is what happens when you watch something for long enough. It begins to reveal a personality hidden behind numbers. I had grown used to its quiet behavior, the kind of slow, predictable evolution we expect from objects wandering the solar wind. So when the magnetic environment around it suddenly transformed, when the field lines surrounding Atlas curved, then bent, then entirely reversed direction, it struck with the force of a revelation. The room around me, lit only by screens and the low shimmer of framework lights, seemed to freeze in place as though the universe itself had paused to ask a question. In that moment, the familiar became foreign. Every assumption I had held about small, icy bodies drifting between stars cracked open like thin ice under heavy footsteps. I remember staring at the magnetometer logs, thinking the software must be wrong, that a line of corrupted packets had slipped into the flow. But the pattern was too clean, too deliberate, too coherent to dismiss. It carried the unmistakable signature of a real physical processor reversal in the near-field magnetic structure of an object far too small to generate one. The behavior was not chaotic or erratic like simple interference. It unfolded with the slow precision of something following a rule we do not yet understand. Before the reversal, the field gradually weakened, tapering like a breath being drawn in. Then came a momentary collapse, a stillness so perfect it felt engineered rather than natural, a magnetic quiet so complete it resembled a vacuum. And from that silence rose the inverted polarity, stable, continuous, as if the space around Atlas had redecided its orientation. The instruments confirmed it again and again, each reading layering certainty upon uncertainty. My first instinct was skepticism after all. In science, the burden of proof lies heaviest on the unexpected. I tested for interference, recalibrated the sensors, reran every diagnostic tool I had at my disposal, even checked for anomalies in the local electrical grid. But nothing changed. The reversal remained locked in place, undeniable and unmoved by my disbelief. Colleagues around the world soon confirmed similar signatures, each report adding depth to the unfolding mystery. What startled many of us was not simply the reversal itself, but the absence of any precursor that could have warned us. No jets, no abrupt brightening, no dust storm, no thermal spike, nothing. Even the plasma density around the object behaved normally until a sudden symmetrical thinning appeared in the data just moments before the flip, as if a tiny pocket of space had quietly hollowed itself out. That subtle cavity, fleeting yet precise, would haunt the later analysis. What mechanism could carve out an ordered void in the solar wind around a body only a few kilometers across? The more we studied, the more the event behaved like something orchestrated, not random. Not intelligent, no, not that, but structured, governed by relationships between fields and materials we do not yet grasp. It was a reminder that in the vast spectrum of cosmic behaviors, we have cataloged only a sliver. In the days that followed, the scientific community slipped into a familiar rhythm of analysis mixed with frustration. The rhythm that arises whenever the universe presents something that fits none of our frameworks. Discussions stretched late into the nights as teams compared spectra, dust curves, plasma readings, and solar wind models. Some researchers proposed that Atlas encountered a turbulent fold in the heliospheric current sheet, a region where magnetic lines of opposite polarity twist like ribbons in a shifting breeze. If the object passed through such a distorted region at precisely the right angle, perhaps the field lines could appear to reverse on a local scale. But this explanation demanded Atlas behave like a conductor or resonator, reacting far more strongly to the solar magnetic environment than any nucleus of its size should. Others speculated that the object might carry ferromagnetic grain-steiny metallic inclusions capable of aligning with fields from its home system, storing a fossilized magnetic imprint from the star it once orbited. If so, our Sun's influence near perihelion might have triggered a realignment of that ancient magnetization. Yet this theory asked us to imagine a structural coherence, something near a single-oriented domain that comets rarely possess. Another group proposed that a plasma bubble, perhaps created by an undetected outburst of charged particles, briefly formed around the nucleus, reshaping the passing magnetic lines like a lens refracting light. But simulations showed such bubbles collapse in seconds. Not across the span of time the reversal persisted. Each idea opened a new door, only to reveal another locked room inside. The more we studied, the more it felt as though Atlas was drawing us into a deeper conversation rather than offering answers. And through this process, a strange thought began to echo among several teams. What if the reversal was not an anomaly, but a recorder response triggered by conditions reminiscent of environments Atlas had encountered long before reaching our solar system? Imagine an object traveling for millions, perhaps billions of years, tracing a silent path between stars, moving through magnetic storms, ancient shock fronts, the turbulent wakes of supernova remnants, or regions where fields twist around the edges of stellar winds. What if some fraction of those experiences had been etched into its composition, the way tree rings record seasons? We have long assumed small interstellar bodies are simple, passive remnants. But what if they carry memories not conscious, of course, but physical imprints of the forces they survived? This idea is speculative, even poetic, yet not incompatible with physics. Materials retain histories. Metals remember magnetic alignments. Crystals preserve deformation patterns. Certain compounds hold lingering polarization. It is not impossible that a body traveling across the galaxy could gather layers of environmental influence, each layer a response to a different encounter. Under this interpretation, the reversal we observed might not be something happening to Atlas, but something being released or reactivated as it enters the domain of our Sun. Such thoughts are not standard astrophysics, yet neither are they fantasy. They remind us that interstellar objects are more than icy rocks. They are messengers from ancient places whose conditions we cannot yet imagine. What startled us most was the silence after the reversal. No turbulence, no oscillation, no gradual return to the original state. The new polarity simply settled in as though it had always been that way. There was something almost philosophical in that quiet stability, a message, if one could call it that, about the universe's indifference to our expectations. The cosmos does not perform for us. It reveals itself when it chooses, often without warning. And when the bow shock around Atlas thickened days later and the plasma density rose with its approach to perihelion, the reversed field persisted, unwavering, as though the object had slipped into a new magnetic identity. All of it suggested that the reversal was not a glitch or transient disturbance, but a transformation one we do not yet know how to interpret. Even now, as I sit alone in the dim glow of control room lights, listening to the gentle hum of the observatory servers, I find myself returning to the same quiet sense of awe that first overtook me the night the lines on the screen twisted into their new form. There is something deeply humbling about watching an interstellar object rewrite assumptions we had believed were settled. It reminds me how young our science truly is, how much of the cosmic landscape remains unmapped, how many forces operate beyond the reach of our equations. Each new dataset that arrives feels like a whisper from a distant past, a fragment of a much larger narrative stretched across time and space. And the more I study the reversed field, the more I wonder what history it represents. What stellar nurseries has Atlas brushed against? What magnetic frontiers has it crossed? What long-forgotten boundaries carved themselves into its structure, waiting patiently for the warmth of a new star to awaken them? I imagine the object drifting silently between the systems of our galaxy, carrying a layered archive of encounters, regions of violent turbulence where young stars sculpted fields like sculptors shaping clay, corridors of calm interstellar medium where its nucleus cooled to darkness, ancient remnants of long-dead stars whose shock waves pressed new signatures into its dust. Perhaps what we observed was not simply a reversal, but the resurfacing of a cosmic memory, a trace awakened by forces we do not yet fully grasp. I cannot prove this. Not yet, but the thought lingers each time I study the stability of the reversed field. We continue monitoring hour after hour, night after night. The telescopes remain fixed on atlas-like instruments pressed against the pulse of a patient, whose heartbeat has taken a surprising turn. Each new reading adds to the portrait we are slowly shaping, one that reflects not only the object's behavior, but our own deepening curiosity. As scientists, we often expect the universe to behave predictably, to stay within the walls we construct with our theories. But every so often, the cosmos opens a door we didn't know existed, and through that doorway comes something that demands we rethink what small bodies can do, what magnetic fields can express, and what interstellar wanderers may carry within them. Atlas has become that doorway. And so, despite the long hours and the uncertainty that stretches ahead like a corridor fading into deep space, I find myself grateful to witness an event that challenges us to listen more closely, to respect the quiet mysteries unfolding just beyond the horizon of our understanding. Somewhere out there, 3i Atlas continues its slow, enigmatic journey, a visitor from another star, carrying with it the memory of a moment when the very structure of the space around it turned inside out. And here, on this small world, we keep our instruments poised, our minds open, and our curiosity sharp, knowing that the universe rarely speaks loudly. Most of the time, its greatest revelations arrive in silence. And so we continue to listen, not for answers, but for the next whisper.